What is up, Nerf Nation? I'm Naptown Nerf, and this is a mod guide for the Star Wars Captain Cassian Jyn Erso Deluxe Nerf Blaster. I have rewired this thing, and I'm going to show you exactly how I did it. We have LiPo power with the revamped fanning motors in there. We also have the sound and LEDs that we can have on or off. And we also have the UV LEDs that will come on when you put in a magazine. You probably can't tell that, but it does. So this mod guide is going to be pretty long, but I'll have a clickable table of contents in the comments pinned. And then I want to give a big shout out to Tom from Foam Data Services. His YouTube channel has been a big help to me actually over the years, and he did a MOSFET guide that I used to rewire this, and then he also did a somewhat of a guide on how to rewire your Captain Cassian or Jyn Erso blaster. So that was very helpful to me, but I want to give him a big thank you. Definitely his videos will also be linked in the description. So if you need extra help, or if there's something that I didn't explain quite well enough, you can watch his videos and maybe he will explain it a little bit better than I did. He probably did. So here's the mod guide. Enjoy. Okay, so these screws are actually quite a bit larger than most Nerf blasters, so you're going to want a number 1 screwdriver and not a 0 size screwdriver like this. So a little bit larger. Go. Take out the battery tray. We will be scrapping the battery tray for a LiPo, but we will need to cut off this end portion here so we can retain the screw port. Alright, you guys, so I figured I'd go ahead and try to explain kind of what's going on here as best as I can. This is basically a strife that has LEDs and sound. So if you think about the main system as a strife, I think that'll help you a little bit. Since we're going to be using a MOSFET, you can keep these switches. You don't have to change them out. I am going to change out the rev switch for a little mini micro switch here, a little cherry switch, just because I like the feel of this a lot better than this. But if you want to keep this, but you don't want the trigger lock, you'll probably just cut this down so this will not connect with this piece of plastic. So you just cut that piece of plastic down, and then you won't have the actual lock there, but you'll still have the rev trigger function. So we'll go ahead and remove this piece because I don't need it, and we'll set the rev trigger aside for now. We'll move the main trigger out of here, and we'll take a look here. So these are your UV LEDs. They're really nicely connected in here. They are attached into this board into your flywheel cage. We will remove those and then wire these up separately. We will have to add in a resistor for those so we don't blow these LEDs, because the resistors for these LEDs are in this panel and we're getting rid of that. So we'll move this out of the way here. Hopefully you guys can see. Obviously this is our speaker. This is our soundboard here, and we will be keeping all of this because I want to keep all this in. I want to add a switch so we can turn this on and off if I decide I don't want sound or lights up here for the pew pew. I can turn that off, and that all runs back into this switch here. This switch is actuated by the trigger here, and when that is pressed down, that's what makes the sound go and the lights go up front here. So we'll keep that. We're going to keep this for sure. So this is our magazine push button release, which is very different from most Nerf blasters. So we definitely want to keep this spring. We're going to need to keep this. If you don't want to keep the magazine lock, you can take that out. But I'm thinking that I might wire my LEDs up to the magazine lock, so when I put a magazine in, the LEDs come on. When I take it out, they'll be off. This board usually has a screw that screws it down, but we can take this out. This goes to all of our switches except for this switch, which is good. So we can get rid of this and then rewire it all. So One thing that's very unfortunate is they have solvent welded these motors into place. I probably am going to keep this cage for the mod guide, so you guys, because there isn't a ton of cages out there. OFP has cages for this, and I do have one, although I think I would rather have a Morpheus cage than this. This is a mid-crust cage, and this also, I'm not sure, I mean, it does fit, but it's a little wobbly, and I don't really know how well it's going to work, because it kind of wobbles in there. So, and I've heard that these don't actually work in here, so I need to do a little more research on the aftermarket cage first before I go into that. But for this mod guide, we're going to keep this. It's going to be a bit of a pain to get these motors out because they are solvent welded, but I think with some force we can get those out. We probably will destroy our motors though, so if you want to keep these motors, do not try to remove them. Make sure you desolder everything here and then rewire accordingly. But with all the aftermarket motors we have, I really don't see a need to ever keep the stock motors. Let's go ahead and try to remove some of these things that we do not need. So we have to remove these ribs to fit our motors. And if you're going to use this stock Nerf cage, you have to do this on every Nerf cage that I've ever used. So you want to remove them carefully because you don't want it to get too loose. So I usually try to remove about half the rib and see how tight that is. And then if I need to remove more, then I do that. And I like to use an X-Acto blade. I have a neat one that's a flat edge here. That's kind of nice, but you can do it with just a normal one too. You just kind of have to work at it a little bit differently. But we're just going to try to get on those ridges and remove some of that and then fit our motors and see how it goes. Alright, we got our motors in there, nice and secure. Make sure you have them opposite of each other, so if the positive is on this side, the positive on the other motor should be on the other side, because then they will spin the way that they need to shoot the dart out. So, alright, so I went ahead and upgraded the flywheels with some blaster parts flywheels. This cage has a pretty small wheel well, so if you I'm not sure a lot of flywheels, aftermarket flywheels, will work, and you will probably have to make some extra room by, either carving down or sanding down some of the edges. I had to just trim off just a little bit right here, I believe, just to get it to rotate smoothly. But it is very, very close here, and these are some of the smallest flywheels that I know of diameter-wise. Okay, so we need to test which way our flywheels are spinning. And I like to use a 9-volt for that. Sometimes these fangs, this 9-volt doesn't even give these fang motors enough juice, but there we go. It seems to be moving in the right direction, so that means our negative will be in front and our positive will be in back. At least for me it will be. You probably should test to make sure it's the same for your motors. So we'll go ahead and wire those up. Okay, you guys, so it is really tight in this motor cage, and I had to actually reverse the wires around to get it to fit, and you want to leave a little slack so these wires can kind of push down a little bit. And I would recommend kind of running them this way because there's a little more room on this side of the motor cage than there is on this side. But hopefully this should close now, but it is a very tight fit. Even 130s are tight in this thing. Alright, you guys, so I went ahead and dremeled out the area in here and in here, and then I had to trim out a little part right here so my switch this wouldn't interfere with my switch when I put the shell together. And then I also snipped out a little part back in here so then I can fit my XT60 back up in that area there when I put my LiPo in. And I'm going to be using this just 1000 milliamp 2S graphene LiPo. This is what I use for a lot of builds that I run 2S on. I really like this LiPo, and it should fit in there just fine. I'll probably show this part before I rewire the whole blaster, because if I did this again, I'd try to do these shell modifications prior to rewiring it, just so you don't have any junk and dust and stuff in the blaster. So, okay, so if you decide to switch out your rev trigger, we're going to have to make room for this, just like you would on any flywheel blaster. So we are going to, I'm actually going to remove the normally closed tab because we will not need that. So I'm going to remove that tab. I'm just going to snip it off just to give us a little more room. And then we will just need the common and the normally open. Okay, so when you place this, you want to make sure that this lever is pushing this all the way out so it's not like loose in the end, but you don't want it to be depressing the button. So we'll just keep that close there, and then when you push, then you can hear that click. So just make sure there's enough room in there. That looks pretty good. Looks like we have enough room there. And I will lock that in using epoxy putty. And then I'll probably put some screws down, maybe one screw or two through these holes if I can find some that fit. Alright, so I just used some toothpick to put in there because I couldn't find any screws thin enough, but this will work just fine. Alright, you guys, so I went ahead and made this cage removable. I don't know if I would recommend doing that, but if you want to do it, this is how I did it. It is very difficult and very tight in here. And basically, I just have my Dean's connector underneath the barrel and nozzle here of the cage. I did have to modify the cage slightly so it would have enough room to fit in there, but it is very tight. So if you don't feel like that's something necessary, don't worry about it. But I do plan on removing this cage and replacing it with a higher crush cage at some point. Just make sure your negative wire is towards the back, because that part is thinner on the Dean's connector. And then you'll just have to file off like a little part of the bottom of this so it'll sit down flush. The positive wire is running on this side. I don't know if you guys can see that. I don't want to mess up my soundboard, but it's running on this side underneath the soundboard, so I just undid the screw and ran my positive on this side and my negative on that side. And yeah, fitting everything into this blaster is definitely going to be tricky, so hopefully that works out. Okay guys, so now we are going to want to take our flyback diode, that the one that you want will be linked in the description along with all the parts, but the silver or gray part needs to go towards the positive and the black part needs to go towards the negative. And I'm putting this right after my motor cage where I've connected it, so if I want to connect in another motor cage, then I don't have to add another diode. So this is why I'm doing it here. We're going to go ahead and strip the red and black wire and then solder that in there. So. so that's soldered on there. That's going to protect our MOSFET, and we will try to fit it into the blaster so we can move on. Alright, so I'm going to go ahead and cut out my placement for the switch here. This will turn on and off the lights and sound, so when I don't want them on I can turn them off, and when I want them on I can turn them on. So I'm just going to cut out a slot here. Next, we need to wire up the positive lead coming from your thermistor here, which was actually what was originally connected to the battery tray. I don't believe I showed myself snipping that off because I'd opened this up previously and already cut the leads to the battery tray. So this black wire here and the red wire coming from the thermistor is what used to be connected to your battery tray. And then we will connect a positive lead into the switch and then run one out, and then that will eventually go into this guy right here. Okay, so I connected that into the middle pin. I'm pretty sure that's correct. If you put one into the middle pin and one to the outside end, it should turn on and off one way or the other. Obviously it's going to depend on your switch, but from what I remember that's correct. And then I'll put this one on the top just to make it easy on myself. And this is just some 22 gauge silicon wire. You do not need thick gauge for this. You will only need thick gauge basically from your motors and then to your battery, and that you can either use probably 16 or 18 gauge silicon wire. If you do decide to put in 180s and cut the shell, or 132s even, you probably should go up to 16 gauge for the motor wire, and I use 16 gauge just because, but you don't probably need 16 gauge for 130 motors. Alright you guys, so we need to set this up so we have 5 volts coming out of it, and that it shouldn't matter what voltage you put in, 5 volts is going to come out, and that's going to protect our soundboard, and that will keep our lights and sound from frying. So we want to hook up some crocodile clips to this, and I just have the AA battery pack. That's only 6 volts going in, but we want 5 volts coming out, and I'm going with the 5 volts. That should be a very safe voltage, and that's what Tom from Foam Data recommended, so that's what I'm going to go with. Right now it's 6 volts going in, 6 volts coming out, so we will turn this down with this, and this could be more or less sensitive depending on the model you have, but we will turn that down. Hopefully we see something here. There we go. Now it's doing something. I had to turn that a lot before it did anything. And now I'm going to turn it back up to get to right at 5. So that should be 5 volts. So that should be good. And now it should be set up so no matter what we put in, that's what we'll get out. Okay, so that's already soldered up. I'm going to leave that there for right now. And then we're going to attack the rest of the blaster. We're going to solder up this basically back to this area about just like you would a normal strife. I did actually add in the spring that was in the lock here. I just threw it in there and it actually works pretty well, and I kind of like that, so I'm going to leave that there, and that'll give me a little more feel there on that, so that's cool. Okay, you guys, we're going to go ahead and set up our MOSFET. Link in the description to the exact type of MOSFET you need. And then you will need a 10K ohm resistor, just one. I have a bunch here, but that tells you what type of resistor you need. So this is the gate, drain, and source. And we will put this connecting the gate to the source. So we will also need some Hink strap to put around that, and just solder that onto those sides. Okay, so the blue wire that's coming from your common on your switch is going to go into the gate, the leftmost pin. Wrap it around there. I have heat shrink already on. It's really helpful to have a good set of handy hands, guys. Let me tell you, it'll save you a lot of headaches. I'll link to where I got my handy hands in the description also. I am so glad I upgraded. They are so much better. Now we're going to connect the negative that comes from your motors, and that is right after where you connected your diode. So you connected your diode, and right after that you're going to figure out how much wire you need. So give yourself a little extra, especially with this thicker stuff. So I'll probably trim it right there, and then we'll connect that to the middle pin. Okay, so now we're going to go ahead and make our connection to the other side of here. I'm going to trim off some of this because I have extra wire here and I know I won't need that much. I'll go ahead and make sure I leave myself enough, but that should be plenty. And then this should be, yeah, I don't exactly know where my XT60 is going to go in here. I still have to probably do some shell cutting in here to make the battery fit and whatnot, so I just want to give myself enough wire there to do that. And we'll do the same with the negative, so I'll just make them the same length. Okay, so now things are getting a little hectic in here, but the positive lead that's going to go to your battery, we need to connect both the lead coming from the motors into that and the lead going to the switch. So both of those will connect into this. We're going to strip that. We're going to connect both of these wires into there. Okay, so I just cut a small piece of black and we're going to connect that to the last pin on our MOSFET, which I believe is the source. And we'll put those together, solder that up, and then this will connect back into the battery lead on the negative. Okay, so I got that soldered up. My heat shrink is ready, but I'm not going to put it on yet because we need to do these LEDs here. And I basically have connected the two black wires together right here, and then I'm going to take this wire and connect it back into the connection here just so it's all together in one spot. You could just take both wires and connect them here too. There's lots of ways to do it, but I decided to do it that way and then just take one wire and connect it in here. So yeah, we'll go ahead and solder those up, and then we'll worry about the positive leads from the LEDs there. So so I got these little things a while back that I can stick onto my shell and then it will hold the wires in, which is kind of cool. And I'm going to use that to kind of hold these wires down to keep them out of the way of the flywheels, because that's obviously very important with all these wires going in here and the flywheels in the same area. You do not want the flywheels rubbing against your MOSFET or any of the wires or anything like that. Okay guys, so let's wire up these LEDs. so we have our switch here, and I'm going to wire it up to the actually magazine lock. And I've already snipped off the red wire because we won't be needing that pin. We want this to be on, the LEDs to be on when this is depressed. So you will have, this is your common, the middle wire, and then this is the normally, ooh, I don't remember now, but I've tested it and this is what works. It would be normally open, I'm assuming. You're gonna connect the middle wire here. So I spliced in a spot to solder this in, and if I was thinking ahead of time, I would have had some shrink wrap already on this, so then it would be more tidy, but I forgot about that when I did this, and now we'll just have to do some electrical tape, but that's no big deal. But we'll have this in here, and we'll probably shorten this wire up, and we'll just solder that right in there. So from the middle pin into your power lead here, and then the wire you just ran extra off of your positive from your LEDs will go to a resistor and then go into the back pin there. The resistor part is a bit tricky because we don't know exactly the voltage of these LEDs, but I'm guessing they're between 3 and 3.2, which means we need like either a 100 ohm or 120 ohm resistor since we're using a 2S LiPo. Now if you're putting in a 3S LiPo and you're running like Neo Hellcats or something, you're going to need more resistance. Okay, so I'm going to go ahead and snip this part off, and so I don't have a lock keeping me from being able to pull the trigger when a magazine's not inserted. But then I will still keep the magazine trigger is what it is now, not a lock, that will turn on my LEDs when a magazine's inserted. So we'll go ahead and snip this off. You can either use a Dremel or some snips on this. There we go. That went flying, but that should be good. Alright, so let's go ahead and test this. I'm going to use just a battery pack. Do not test with a LiPo, especially when using alligator clips. So we'll test this and make sure things are working. We'll go ahead. Let's see, I don't know which ways. Okay. Turn this on. So lights and sound obviously are working there, so that's good. Then we can push this to see if our LEDs come on, and they do. That's really cool. And then I don't think I have enough juice for my motors to turn on, so we will, but that should work just fine. I can see them trying to turn there, but sometimes the AA packs don't have enough power or amperage to push these awesome motors like the Neo Rhinos or the Fangs. So I've seen that before in testing, so I'm not too worried about that. I'm going to lock down this switch with some epoxy putty, and then we're ready to connect our XT60 connector. And alright, one last thing we need to do before we close this thing up is cut this guy off. And we want to remove the tabs here before we use a Dremel on it. So I usually just pull that tab back and then use some needle nose pliers to pull these out. There we go. That was pretty easy. Okay. And that will fit right down in there like that. And then we'll just glue that there. We'll just glue that to that side there and we'll be set. Okay, I'll probably use 2-part epoxy for that. Alright, so I connected my LiPo and looks like those are working fine. LEDs are working fine. Sound and pew LEDs up front are working fine. So yeah, that worked out really well. Hopefully it continues to work well. This is very new and something cool for me, and I will probably use MOSFETs a lot more in the future, especially for builds that have very little space. Alright you guys, let's go ahead and put this thing over the chronograph and see what kind of performance we get. UV technology turns on when you put the magazine in, turns off when you take it out, just like we wanted. We can pew pew with this on, so here we go.
86, 103, 100. We'll go ahead and turn the sound and lights off. 99, 88. Now we'll use some AccuFakes. 77, 90, 98, 89, 95, 97, 92, 91, 92, 93. So with those Screaming Fang revamp motors, it's kind of hard to hear all the sound, but we do have sound and lights, and then we can turn it off. We don't have it then. So thank you guys so much for watching this mod guide of the Star Wars Captain Cassian / Jyn Erso Deluxe Blaster. If you like this video, please smash that like button. I spent a ton of hours doing this mod guide and a ton of hours editing it, so I really would appreciate it. Please subscribe, and as always, peace out.